Okay, so yesterday we talked about different properties of quadratic functions. Today we're going to use some of those properties to help with optimization problems. Okay, so optimization problems are where you're trying to find a maximum amount. In this case of revenue is what we're going to be focusing on. And so you have the manager of a theater production group, and they're evaluating the price of tickets. Because of course we want to sell the most amount of tickets for the most amount of money possible. So they analyzed last year that the cost was $48 and they sold an average of 550 tickets. So this manager estimates that for each $3 increase to the price, 25 fewer tickets will be sold. So notice here it says for each $3 increase. That doesn't mean they're increasing the price to 51. That means they want to find the best number and how many times they should increase it by $3. Okay, if they increase it to 51, they're going to lose 25. They increase it 3 more to 54, then they're going to lose 50 tickets. So they're trying to figure out what is the best ticket price so they can make the most amount of money. So A is asking us to define variables and write a function to represent the situation. So I'm going to help you with that. So our variable X is going to be the number or the amount of $3 price increases. Okay, so it's the number of $3 increases. So remember, it's not just a flat $3. They want to know how many times they can do that to make the most amount of revenue. Okay, so revenue is money. So when you're reading through one of these questions in your book, sometimes it is helpful to organize the important information. So what we know is it's $48 per ticket, and they sold 550 tickets. I always think it's a great first step to organize your information when you have story problems, because at least that gets it out of the text. And then we know for each $3 increase, you're going to sell 25 fewer tickets. All right, so we defined the variables like they asked us to. Now we are going to write a function. So it says define variables and write a function to represent the situation. So when we're writing a function, I'm going to give you an equation with words that you can use for different situations. So this is about the price of tickets. So you're always going to make one of your values about the price. In this case, it happens to be about tickets. And then your Y value is the revenue, right? How do we find how much money they make? We take the price and we multiply it by what? Yeah, the number of tickets that you sell, right? Okay, so we defined our variables. The Y was the revenue. And so revenue is generated by multiplying the price of each ticket by the number of tickets sold. So what we're going to do is we're going to come up with an expression for each of those. Okay, so the price of each ticket, it's starting off at $48, and then we're going to increase it by $3. So notice how both of these, the 48 and the 3, those are the two that have to deal with the price. Now the X goes next to the 3 because, like I said, we don't know how many times we're going to increase it by $3. Okay, the next one is going to be about the amount of tickets sold. So you're going to start with 550 tickets. And if you're selling fewer, you're going to use subtraction. Okay, if it was a case where you were selling more, you would use addition. So it's 25 fewer tickets here. And then we get to FOIL. So it says to write a function to represent this situation. You can leave your function like this. Okay, or you can simplify it. We are going to simplify it because I just had you read through these. You may have noticed in B, it says how much should each ticket cost to maximize the revenue. So remember yesterday we found out how to find the maximum. Do you guys remember what we used to find the maximum? There's an equation. Yep. X equals the opposite of B over 2A, and then you plug it back in to find the Y. So in order to do that, we are going to FOIL. Do you guys remember how to FOIL? There, that, yes. I like feel. Any of you feel? I really like do the inside first. Okay, so I'm just going to give you a quick thing because I want you to FOIL this, and yes, you can use your calculator with that. So when you FOIL, remember you do first x times x, x squared. I like to do the inside and then the outside. See how it makes a happy little guy? Nose and mouth. So 5 minus 3 is 2x, and then here we get negative 15. Doesn't he look happy? He just has some crazy brows going on. Or maybe that could be his hair. Yeah. Okay, so do you guys think that you could FOIL this for me with your calculator? So 48 times 550, let's write it all out, and then we'll simplify it together, okay? Just need a sign. All right, so we're working with some bigger numbers. Can we handle it? Okay, so let's do it then. So 48 times 550, what do we get? Good, 26,400. And then, like I said, I like to do the inside first. It doesn't matter which one you do first. You are going to end up combining your like terms. Okay, and then we're going to write this in standard form. Okay, so the negative 75x squared is going to go first. And then because these are like terms, we can just subtract. Okay, so if they ask you for a function, you could also write this as your function. Okay, this is your quadratic equation. Okay, and if you notice you have a negative here, so it's opening down, that produces a maximum. So you're trying to figure out how much each ticket should cost, okay, to maximize the revenue. Well, we said the price of each ticket is 48 plus 3x, right? So if your price of each ticket is 48 plus 3x, what do we have to find? We have to find x. Okay, so to maximize the revenue, we have to find the x coordinate of the maximum. Okay, and remember the maximum is the same thing as the vertex. So to figure out how much each ticket should cost, because we know the price is 48 plus 3x, we have to find our x. So we're going to use the opposite of b over 2a. So I'm going to use my equation. My b value is 450, so it's a negative 450 over 2 times negative 75. So this is exactly what we did yesterday when we were doing our graph, okay? And then we're just going to simplify. We're just going to divide. If you want, you can always divide what you know. Like you know you can divide by 10. 45 divided by 15 is going to be 3, so that turns out very nice. So again, remember, this is x equals 3. This is the number of $3 increases. So you're increasing by $3 each time. So you could probably do that part in your head just by listening to what I just said. You can also just use this as 48 plus 3x, and you can substitute 3 in there. So 48 plus 9 is 57. Okay, so how much should each ticket cost to maximize the revenue? $57. Okay, now we are going to use this for something else, just so you know, but we're going to go to part C that says to find the domain and range in context. The reason they specify in context of this situation is because every quadratic function has a domain of what? What did we talk about yesterday? All real numbers. But in this case, we have a real world problem, right? Okay, it's not going to be all real numbers because we have this function that deals with the price and the number of tickets sold. So the price can't be what? Can't be negative, right? So technically it could be 0. You don't have to sell anything, okay? But it can't be negative. And what else can't be negative? Yeah, your amount of tickets sold. Okay, so I'm just going to make a little note for you. Okay, so for the domain, we know the price and the number of tickets sold. Can't be negative. That's what it means in context of the situation. So what we're going to have to do is we're going to have to find a way to mathematically set that up. So can you guys tell me in symbols how we could write it can't be negative? Greater than or equal to 0. Great. So technically it can be 0, it just can't be negative. So we're going to go back to our function. So this is our function, right? And domain has to do with the x. So we know that 48 plus 3x, that has to be greater than or equal to 0. Okay, that's the price. The number of tickets sold is 550 minus 25x. So that also has to be greater than or equal to 0. So these two things have to happen at the same time. So will you guys make sure you put an and in between and not an or? Because that's going to relate to something else that we're doing. Okay, and then will you guys just solve each one of those for x, please? So we solved inequalities before. We treat it just like an equal sign. So there's multiple different ways that you can solve these. I would move the 48 over to keep whatever's in front of x positive, but not a big deal if you did it the other way. Just make sure that you flip your sign. Okay, now we talked about how it can't be negative. So this is going to happen. One of your expressions when you solve the inequality is going to result in a negative, and you're going to adjust it. Okay, so because it can't be negative, all we're going to do is adjust it to x is greater than or equal to 0. Okay, so you're going to do the adjusting for the context. Okay, and then if we solve over here, I would add the 25x over. Again, that's just to keep whatever's in front positive. Okay, and then Z, what did you get on this side? 22? Okay, so then these are our two situations here, all right? So I'm gonna write them out. So we have x is greater than or equal to 0, and this says x is less than or equal to 22. When you have the and, okay, when you have an and situation, you are going to write that as one inequality. So it's going to be x such that 0 is greater than or equal to x. Okay, so notice that the symbol is still in the x there. Bless you. Okay, and then that's greater than or equal to 22. Okay, so again, with your x values, can't be negative. Both of them have to happen at the same time, so we create one inequality. With the range, you can start the setup the same way. Bless you. So remember, the range has to deal with y. We said that y was the revenue. Can revenue be negative? Nope. So it's going to be y such that 0 is less than or equal to y. Okay, so revenue has to be greater than or equal to 0. And then for the range, you're trying to find the height of the graph. The height of the graph, the tallest point is going to be where? It's going to be at the vertex. So all I have to do is find the y-coordinate of the vertex. Okay, so your revenue has to be positive, so it has to be greater than or equal to 0. Okay, and then we have to find that y-coordinate of the vertex. Well, we already found the x-coordinate. How do you find the y? Plug it into where? Your equation right here. Okay, so to find your y-coordinate of your max, okay, we found that x was equal to 3. We're going to plug it into our equation. Y equals negative 75. Notice I'm just writing all of these except I'm going to insert the 3. Okay, and we can put this entire thing in our graphing calculator or any calculator. Okay, so just you can put that in with your parentheses, and then when you write down your value for y, and then go ahead and plug that into your range. I wrote this out wrong. This should be the 400. Then you plug in the 26,000. Okay, so for here you have the 26,400. Okay, and then what do you guys get for your y value? Toby, what'd you get? Okay, so then your y value is going to go to 27,075. Okay, so can you guys just double check, make sure that you can get that? Okay, and that is your domain and range in your contract. All right, and then I want you guys to read through 3B and see if you can set up your function. Okay, so for 3B, we have a very similar situation, right? There's still tickets being sold at $70 per ticket. There were 1,350 lawn seats sold, okay? And they estimate for each $2 increase, they're going to sell 30 fewer tickets. So in A, they're asking you how much did the ticket provider charge in order to maximize profit. So again, we see that word maximize. So that should tell you that we're finding the what? The maximum. And then again, it's saying how much should they charge? That's very similar to what we did in part B, where they were asking you what the ticket cost should be. Okay, so whenever you're trying to find that, the ticket provider, the maximize, you are going to find your vertex. All right, so let's start off by setting up our equation. Now, they aren't making you define variables, but we're still going to have y equals, and we're still talking about revenue, right? So how much money that they're bringing in. So the way that you determine that is still the price of your ticket multiplied by the number of items you sell, which in this case, again, is tickets or lawn seats, okay? So with your row, I want you guys to come up with each expression, and then if you're feeling confident, you can go ahead and FOIL, but I want you to talk to people in the row. All right, and then Maya, can you tell me what you guys got for the price of the ticket?
Oh, just setting up.
Yeah,
okay.
yeah.
What does 350 minus 38?
Okay, that'll be for the number of tickets sold. I will take it. So the number of tickets sold is the 1350 minus the 30 decrease. Okay, good. And then Nina, what did you guys come up with for the price?
So I said 7 plus 2.
Good. Okay, so the price is the $70 plus the $2 increase. Some of your problems might have a decrease. So how would that change? Yeah, be a minus. Okay. And then for this one, you have the 13 lawn seats, and they're going to sell 30 fewer tickets. That's why you have the minus. If there's an increase, you would change it to a plus. All right, and so now we can FOIL. Okay, so 70 times 1350, we should have got 94,500. I like to do the inside first, so I got 2700x minus 2100x minus 60x squared. Okay, then we're just going to organize this so it's in standard form. So I have negative 60x squared plus 2700x, okay, plus 94,500. So this is our quadratic equation. Now we're ready to find the x coordinate of the vertex.
What about, wouldn't it be 600?
Oh, sorry. Yes, it would be 600. Sorry. Thank you for telling me. 600. Yes. Okay, so the 2700 minus the 2100 is your 600, and then we're going to do the opposite of b over 2a. Okay, so we're going to do the opposite of 600, and then 2 times negative 60. Okay, good work. Do you guys have any questions about getting this? About foiling and getting that value? All right, then we can simplify. So 60 divided by 12, that's just 5. So when we're doing the price, okay, we know that the price of the ticket is 70 plus 2x. And for x, we can now plug in the value of 5. So 70 plus 10 is going to be $80. So $80 per ticket is how much they should charge. And we have now answered the question in part A. Okay, now for part B, they're asking you to find the domain and range in context. So again, we just have to keep in mind that our values have to be non-negative. All right, so we're going to set this up in the same fashion that we did in part C. Okay, so we know that whatever the price is, that has to be greater than 0, and the number of tickets has to be greater than 0, greater than or equal to 0. Okay, it can be 0. Do you guys think you can plug in these and then solve for x? Because your price is 70 plus 2x, right? Okay, so I'll give you a minute to solve those for x. Remember, it's okay when one of them is negative. You adjust that. Okay, so can you guys solve that? Okay, and remember I said I like to keep my x's positive here, so I'm going to move over the 70, divide by 2, And then I know whenever I get something that's negative, you have to adjust it. Okay, because it can't be negative. So if it can't be negative, you just adjust it to greater than or equal to 0. Okay, and then for this one, we got 45 is greater than or equal to x. Okay, so what has to happen is x has to be greater than or equal to 0 and x has to be less than or equal to 45. So let's go ahead and put that in our domain, x such that 0 is less than or equal to x, which is less than or equal to 45. Okay, for our range, we know that the revenue, the least amount is 0. We have to find the max amount. Okay, so what we're going to do is we're going to take our x value, we're just going to plug it in to our function. Okay, so to find the y coordinate, if x equals 5, we can just do y equals negative 60. 5 squared plus 600x. Okay, and again, you can just calculate that all at one time. Use your parentheses. Okay, and then go ahead and put that value in your range. All right, what do we get? 96,000. All right, you guys think you got those? All right, so your homework assignment I will put up there. It covers the past 2 days. And then you do need to put your graphs on graph paper, so if you need some, I have some in the bin back here.